This is my Calculus and Vector CCT by Sarah Yoshida for Mr. Wills, kidding, period 3 class for April 30th, 2013. So the question I was assigned to instruct can be found on page 138 of the textbook. It is question number 3, and it reads as follows. The cost, C, in dollars of making X large combo pizzas at a local pizzeria can be modeled by the function C of X equals negative 0.001x cubed plus 0.025x squared plus 4x, and the price per large combo pizza is $17.50. Determine A, the revenue function, B, the marginal revenue function, C, the profit function, D, the marginal profit function, and E, the marginal revenue and marginal profit for the sale of 300 large combo pizzas. So before I get into solving this problem, I wanted to take a look at the different business economic functions that we're going to use in order to solve the problem. So the first function that we look at is called the cost function and is modeled by C of x equals negative 0.001x cubed plus 0.025x squared plus 4x. So what does this equation represent? This equation, the cost function, pertains to the total cost of producing x units of a product or service. So in the case of this particular problem, the cost function C of x is the cost of producing x amounts of large combo pizzas. So let's go back for a second. Why don't we say that x represents the number of large combo pizzas? So the second function I just want to touch on is called the price function or the demand function, which is represented by the notation little p of x. So this function isn't asked for in the problem itself, but we do need it in order to solve for the revenue function, which I will talk about next. So we need to infer that we need to solve for this. So the price function is basically just telling us how much one unit of our good or service, so in our case our pizza, will sell for. And this is actually given to us in the problem. It says that one pizza will sell for $17.50. So therefore our function little p of x, our price function, equals $17.50. So that is the price at which one of our pizzas will sell for. So the third function we're going to look at is called the revenue function, and it's represented by the notation r of x. I'm not going to solve for it because it asks me to do this in part A of the problem, but I will give the formula and explain it in context of the problem. So r of x equals x times little p of x, which is our price function. And remember we said that x represents the number of large combo pizzas, and p of x is our price function, which is the price of one pizza. So by multiplying these two things together, we can find the total amount of money we're making back on sales. We're not taking into account how much we're spending to make these pizzas, we're just looking at how much we're getting in total. And the fourth function that we're going to look at, the last one, is called the profit function, which is represented by the notation big P of x. So basically with the profit function, we're looking at how much the producer is making back, taking into consideration how much they're putting out to make their goods. So this equation can be modeled by big P of x equals the revenue function, so r of x, minus the cost function, c of x. By finding the difference, we can find how much the producer is profiting from sales. So now we can get right into part A of our problem, which asks us for the revenue function. We just said that the notation for the revenue function is r of x, and that equals x, the number of pizzas sold, times our price function, little p of x, which we determined to be $17.50. Once again, that's the price of one pizza. So we can write that r of x equals x times $17.50. We're just substituting that value in for the price function. So we can rearrange that and say that r of x equals 1750x, and that function tells us how much money we're making back in total. So our therefore statement reads, therefore the revenue function is r of x equals 1750x. So now we can move on to part B of our problem, which asks us for the marginal revenue function. I haven't really talked about what the term marginal means, but I'll touch upon it now. Marginal is an economic term, which basically means the instantaneous rate of change. So in terms of this question, we're asked for the marginal revenue function, which basically means the revenue we're making back at a specific point in sales, so at a specific number of pizzas sold. We know that to solve for an IROC, we need the first derivative. So really what this question is looking for is r prime x, the first derivative of our revenue function. Now we know that our revenue function r of x equals 1750x, that's what we just solved for in part A, and that there is a linear function, which means that we can use the linear function rule to solve our first derivatives. This rule states that if f of x equals mx plus b, then f prime x just equals m. Going back to our revenue function, we have r of x equals 1750x. We have no b value here, so we can just say that our m is 1750, and by looking at the linear function rule for first derivatives, we can see that r prime x is just going to equal 1750. So therefore we can say that our marginal revenue function, r prime x, equals 1750. So part C of our problem asks us to solve for the profit function, which we already talked about, as it's notated by big P of x, which equals r of x, our revenue function, minus c of x, our cost function. The difference gives us our profit. So we know our r of x, our revenue function, is 1750x, which we solved in part A. And we know that our c of x is negative 0.001x cubed plus 0.025x squared plus 4x, as it's given to us in the problem. So now we just substitute those values in to solve for our profit function. So we're going to have P of x equals 1750x minus negative 0.001x cubed plus 0.025x squared plus 4x. We're going to distribute that negative. And now we're just going to collect like terms, order our exponents, and solve. So our final answer is going to be big P of x equals 0.001x cubed minus 0.025x squared plus 13.5x. And now we can just write our therefore statement. So therefore our profit function, big P of x, equals 0.001x cubed minus 0.025x squared plus 13.5x. Part D now asks us for the marginal profit function, and we already talked about marginal meaning first derivative, so in this problem we're solving for P prime x. So we know that our P of x equals 0.001x cubed minus 0.025x squared plus 13.5x, as we solve for in part C. So for this derivative, we're going to use the power rule for first derivatives, which states that if f of x equals x to the power of n, then f prime x is going to equal n times x to the power of n minus 1. So we're going to apply this rule to each term of p of x to get our first derivative. So therefore we can say that p prime x equals 3, because we're bringing that exponent down. So we're going to bring down the 3, and we're going to multiply it by 0.001x, and then we're going to have to the power of 3 minus 1, because 3 is our n. And then we're going to minus 2, we're bringing that exponent 2 down, times 0.025x, and then to the exponent we're going to have 2 minus 1, because 2 is our n. And the third term, we have an imaginary 1 there, so we're going to bring that 1 down, 1 times 13.5x, and then to the power of 1 minus 1, which is just going to be 0. So we're going to end up with an answer of, we're going to just expand these terms, so 0.003x to the power of 2 minus 0.05x, and then plus 13.5, and then you have x to the 0, which is just 1. So that term is just going to be 13.5. So our final answer is p prime x equals 0.003x squared minus 0.05x plus 13.5. We can use this function to find the profit at any particular value of x. So for our therefore statement, we can write that our marginal profit function is p prime x equals 0.003x squared minus 0.05x plus 13.5. Party asks us to solve for the marginal revenue and marginal profit for the sale of 300 large combo pizzas. So we're going to start off by saying that x equals 300, and we're going to solve for our marginal revenue first. So we know that our marginal revenue is r prime x equals 1750. If we plug in 300 there, we know that r prime 300 is still going to equal 1750, and this just basically means that on the sale of the 300 pizza, we are getting 1750 back, and this is constant for every sale of pizza. So that's just saying that it doesn't matter if we sell one pizza, 100 pizzas, 1,000 pizzas, a million pizzas, we're always going to make $17.50 on each pizza. So therefore we can say that for the sale of 300 pizzas, the marginal revenue we make is $17.50. So lastly, we're just going to solve for the marginal profit for the sale of 300 pizzas. So we're just going to use our p prime x, which we solve for. P prime x equals 0.003x squared minus 0.05x plus 13.5. We're just going to substitute 300 in for all the x values, so we get 0.003 times 300 squared minus 0.05 times 300 plus 13.5, which gives us 270 minus 15 plus 13.5, which gives us 268.50, and therefore we can say that the marginal profit for the sale of 300 pizzas is $268.50. This value simply means that on the 300 pizza, this is how much money we're profiting. So we've now just finished parts A, B, C, D, and E of our problem. Questions such as these are an example of how calculus is used for economics in the real world. Calculus is a study of rates of change in the form of derivatives. We just saw how economic models such as the revenue and the profit function can help make projections about sales, so one can see how it is useful to companies and businesses in the real world.